Hi, let's come back and try to figure out our problem. The problem before is that our simulation data is too huge. It's really hard to deal with. So to avoid this situation, let's change back to 10 by 10 by 10, all right? And then step size. We can use the same simulations, but changing this to 3000. Okay. Let's run this simulation again. No hub. MPI run. Minus MP4. Okay, it's finished. And then I'm going to convert this trajectory to what we have. Okay, this is actually quick. So we're going to process this again by changing this. So it's only 3000 beat, and the box size is, we have 100 frame, the box size 10. Hold on. The box size is 10. Okay. So let's perform this RDF. We're still very okay. It's actually quicker. It's actually quicker. So let me actually just change it to 10 frame. Okay, just need 10 frame. Okay, but this number is crazy enough. We have these 1, 2, 3. So this is 1 billion, 10 billion, 10 billion data we have. Okay, this is that. Is that reasonable? 3000, 3000. Oh, 3000 times 3000. See that's it's a tricky, always a tricky question about programming and simulation, about the system size, number of particle, because sometimes you can have very huge amount of data to calculate, to input, to deal with. So but let's say we keep it that way, all right? Can I open this file? Okay, even opening it, is very huge, all right? Okay, it's a huge amount of data we have. And then since we already have this disk file, let's make things simpler by creating another program. Okay, and we're going to RDF2, and we're going to just read this file 10. Ideally I should write that in, I should written this, all the function into one program, but this is just to show you how to process the data. All right, so file equals say dist.txt, and first we need to go through the very large number, at least larger than this number, right? 5, 8 digits, so 9 digit. Okay, good. So I sort of need this 4i, and then let's first go through the file and determine the number of frame we have. So number of frame equals I minus 1. All right. So close 10 again. And then I allocate my array. I allocate my array into it's a distance array, distance array in F. So it's a real number. Okay. And then going to fetch the data 1, 2, 3, 4. 4, actually 6. So going to open it again from 1 to end frame. I'm going to read distance I. Close 10. Let's first try whether it is correct, alright? M frame. Okay. And then we're going to sort this data. So we need a minimum, the lower RDF low equals minimum value of this disk, and RDF high is the maximum value, and we need a resolution, right? We need a resolution. M being, so say M being equals, how about 100? Just 100. So we just need to count the bin size, X bin, so the bin size, RDF, the bin size, hold on, how can I call it? Just call it X bin, equals maximum value equals RDF high minus RDF low divided by M bin. And then we need to have an array called RDFI. So this is the array we have. So RDFI is this large. Okay. So, and we need to put a 0. RDFI equals 0. So when my, okay, I need this loop right now. 1, 2, 3. Now just calculate the distance, right? So this distance minus RDF low, okay, minus RDF low divided by X bin, all right, is the position of the RDF, all right? So this is the position of RDF. That's called the RDFI. All right. And we also need to take the, do I need to take the integer? Yeah, I need to take the integer of this. So integer of this is the position of, wait, we already call it RDFI, so need to call, let's call it K, okay, although this is meaningless. Okay, so RDFI K equals RDFI K plus 1, all right? Okay then, yeah, I guess that's it. So from 1 to NF, I calculate all of these positions, and then I just need to normalize. It. RDFI equals RDFI divided by M bin. Oh no, NF. Real double NF. And then I can just write this to the screen. Okay, probably will make a smaller value, just 20. All right, let's see whether that works. Okay, how many? I'm going to write it to screen, all right, and see. I'm going to write it to screen. Right. So it's RDF low plus number of X bin. This. Okay. So I guess that's the program, all right? Can I declare everything we have here? So many. And being RDFI declare already. Some file NF already. This already. RDF low RDFI, all right. RDF low, RDF high, X bin. Okay, should be the. Okay, actually works. Needs to take a while for the sorting. I haven't. Hold on. Did I close the file? I didn't close the file. Okay, something bad could happen. So let's check our file here. Okay, so actually, oh, it is not gone. It's still there. All right. So since it's a really large file, I want to check whether the progress of the program. All right. So let's put things here. So let's say right opening the file first time, and then open the file the second time. And finish opening the file second time, and then right calculating RDF. All right, and then most importantly, wait, I do close that file. All right, I do close the file after I get this information. Okay, it may not be the bad program, but to make it easier to process this case study, I want to do one thing is to shrink the file. Okay, how can I do it? I just go to a certain distance. I think just 1 million of data, and I'll truncate the rest of it. Okay, it is frozen. Okay, I need to open it again, this data. Okay, and I'm going to go to the last line. I'm going to truncate this. Oh, it's dying. Okay, this is the data is too huge to deal with still. Let's just try running the simulation and see, or running the program and see whether that can process. Okay. Okay, let's close this. Let's run the simulation, run the program. Oh, that really takes a while, even for opening the first time. No, it's okay. We have time. We'll just wait. Okay, still that's way too long. So meanwhile, we can try running our simulation again and make a smaller file. All right, just take it to 1 frame, and we run the rdf.exe first. Oh wait, hold on. Processing frame 1. Okay, this is 4. That should be reasonably enough. Okay, we should run this file again. I think something is wrong with the program, or actually not. Open this.txt, right? Read. That is not a huge file already. All right, but still, that's. How about let's truncate? Let's go to here and then we truncate. Okay, I can do this. Okay, how many lines do we have already? 3, 4, 5, 6, 7. Oh, I see. Because when I delete the file, delete the okay, actually it is working right now. I only save 1 million lines here. So I shrink the file. So that's wrong it again. Oh no. Oh no. Sorry. Okay. Need to do that again. Okay, 1 million lines here. And then I'm going to run this 2. All right, open it the first time. I hope it's quicker. This is not right. This is not right. It's only 1 million lines, right? It's only 1 million lines. That shouldn't be hard to deal with. I think there's something wrong with the program. RDF2 type 90. Okay, so RDF2, open the file, open 10. Okay, from here, right, and do. Okay, NF. So I allocate. You know, that's right. I don't believe it. I don't believe it. So G4chain minus RDF2.exe, RDF2.f90. So RDF2. See, something is wrong. Something is not right here. Opening the file for the first time. Open file. Aha! Stupid. I didn't read through the file. I read in front of the screen. That's the reason. Alright? That's the reason. Stupid. See? You know, that's the exciting part of writing your own program, that you always want to do something and you're struggling. You keep fighting for that, and in the end you realize you just did something stupid. It's same for the life, all right? So voila. Okay, I probably will stop here, okay? So just want to draw. Can I draw? No, not this Excel. I hope it is a curve, right? I hope this is a curve. So let me draw. It's a curve. It's a weird curve. Supposedly it should be the RDF, but you can see there's something wrong, right? So we have to go back to fix the program. But I will stop here. And going to finish the code, and then you can do the same, and you can realize that how difficult it is to generate the program that really works, all right?